Okay, that was quick, but I managed to have a sip of my coffee. So the next talk, as I was mentioning, is recorded as well. Is by Jason. Cool. And it's also, I don't know, I really, I might sound biased, but the topic is really interesting as well. I hope that you enjoyed the talk. I will try to share it now. So this is the one, and I hope you enjoy.
Hi, everyone. Welcome to our session on graph databases for Monty Python developers. My name is Jason Koo. I'm a developer advocate at Neo4j. And as I presume everyone here knows, the Python programming language was named after the BBC comedy group Monty Python and their famous TV series Flying Circus. Now, the six gentlemen who were responsible for creating, writing, and acting in the series also went on to create a series of movies. Their second movie being Monty Python and the Holy Grail. Now, this movie was produced in part by a man named Mark Forstater. Now, Mark went on to actually sue the group later on when they created a musical based off of the movie Monty Python and the Holy Grail. That lawsuit resulted in enough money that the group decided to get together and produce a live show to help pay it off. Now, that live show was so popular, it got extended to, I think, 8 additional events. Basically, it went from 2013 to 2014, which was the year that Fernando Perez and Brian Granger released Jupiter. Now, this short traversal story is an example of the type of information you can glean and traverse through in a knowledge graph. And a knowledge graph is an example of what you can do with a graph database. Now, graph databases. Okay, technically, what are they? Okay, so in broad terms, they are a type of NoSQL database, alongside with document, key value, and column family databases. And here on the right, I've listed some of the many famous companies and services that are available for these other NoSQL options. Now, what makes a graph database different than these other data stores is how the relationship data is stored, right? So we've got two main things in a graph database. We've got nodes and we've got relationships. If you're coming from a graph theory background, and a node would be a vertex, a relationship is an edge. And nodes are, you can think of like typical information you would have in a tabular database would be like one row in a table is a node, right? So here, for example, we've got the Black Knight. He's a node, and we've got the bridge as another node. It's a location, and here relationship is creating a context between these two nodes, right? So here we can say the Black Knight is guarding the bridge, and in a graph database, the relationship component is a first-class data citizen, so it is stored along with the nodes. Now, this is different from other databases that typically don't store the relationship, right? That is something that is created temporarily by a join statement, for example. Okay, so in a graph database, you can also put properties with both relationships and nodes. So, for example, we're giving a name to this node, which is the Black Knight. We could attach an image URL, date of birth, social security number, et cetera, et cetera. And relationships can also be given properties. So we could weight the value of him guarding the bridge, right? Like how long has he been guarding the bridge? How well has he been guarding the bridge? This can be put into a graph database. And this kind of graph database that stores properties with relationships and nodes are known as property graphs. Okay. Graph databases in general. So some of the general pros is, again, you don't have to do these sort of fugly joins. And the schema is optional. So you, of course, having constraints and indexes will make queries much faster, but you can just start putting information right into a graph database, and you can give labels to nodes or assign types and properties after the fact or down the road. So it's very easy to iterate through your data model and your schema. And if you're using a visualization tool, data analysis and data discovery is actually quite intuitive. So, for example, say we want to play a complicated version of the Kevin Bacon game, where we want to find the relationship paths between all the main actors from The Matrix with the main actors from Monty Python and the Holy Grail. Okay, so if we have this information in a graph database and we query it, we could get something like this. So here on the far left, is Monty Python movie and 4 main actors, 4 of the 6 Monty Python crew. And on the far right is The Matrix with 4 of the main actors, Lawrence Fishburne, Carrie Ann Moss, Keanu Reeves, Hugo Weaving. And here we can see in the graph, we can see very quickly that there is no one-hop connection between any of the actors, right? So there's at least 1, if not 2, degrees of separation between the 2 sets of actors. And one of the more interesting connections is actually at the very top, if you can see it, with Sean Connery, who had worked with Terry Gilliam and actually Michael Palin both together on Time Bandits, and then also with Lawrence Fishburne later on Just Cause. So and Sean Connery's connection with Time Bandits is actually interesting. He was written into the original script as a joke because Terry Gilliam and Michael Palin didn't think they would actually get Sean Connery. But it ends up, Sean Connery was actually a fan of Monty Python. And so when he had caught wind that he was actually written into the script, he said yes immediately. And Terry Gilliam, I think, attributed Sean Connery as saving the movie because I think the year that it came out, it was competing with quite a few interesting movies. Anyways, so that this sort of information you can quickly peruse through when it's attached to a graph visualization tool. Okay, some cons. So you wouldn't want to use a graph database for pure transaction, pure logging information, right? So if you need to record data, but you don't plan on really analyzing the data immediately or anytime soon, then a graph database isn't going to help you. Isn't going to be above and beyond the other options out there. Okay, and if you need a quick cheat sheet, I love this graph from the Manning's book, Introducing Data Science. So here we've got XY chart here. So on the y-axis, we got the size of data from small to large, and on the x-axis, from simple amounts of data to complex amounts of data, right? So if you are just wanting to store a ton of data, but it's fairly simple, of course, use a key value store. But if you want to contain really interconnected complex data, you should really use or consider a graph database. Now, what's an example of like complex data? So fraud detection is a great use case for graph databases. So if you're trying to detect fraud, right, you're hopping through multiple domains, right? Maybe emails, documents, banks, address, location. There's quite a bit of various different typically siloed pieces of data that you would want to pull together to look for fraudulent behavior. Another example of this would be like trying to build a spam detection system, right? So spam, by the way, originally began with a Monty Python skit, also just named Spam, I believe. And through, quite a, I won't go into it, but this scene, this skit, ended up becoming what we now know as spam in terms of email, as unwanted, unsolicited content, which actually drove the company that produces spam a little nuts at first. And they tried to fight it, or I think they tried to sue tech companies. I forget the exact details. But anyways, they were totally against this, obviously, at first. But eventually they turned around. They just embraced it, which led them to actually sponsor the creation of Monty Python's Spam-A-Lot musical that ended up getting them sued. Okay, so who are the major players in this space? There are quite a few databases now. The space has been around for a while. And according to DB Engines, which is a website that uses a number of various other resources and then combines it all and uses some magical algorithm to score the different graph databases. And then here we've got this chart here. So here we're just listing the top 10 graph databases. As you can see here from their ranking, Neo4j and Microsoft's Cosmos DB are at the top, followed by many other still well-known graph databases. Okay, so if you never used any graph database and you're looking to start one, I would start with obviously this list. But something to obviously consider as with any sort of tech project is what is the skill set of your existing team, right? Like, does anyone have existing knowledge of graph query languages on their own? Are you an AWS house? So take that all into consideration when you look at this. But if you just want to start from scratch, this is DB Engines is a great place to start looking. Okay, so graph databases in general could be broken up into three broad categories. We talked about property graphs earlier. The next one I'd like to talk about are semantic graphs. Yes, so semantic graphs are a bit different than property graphs in that everything is stored in triples, right? So everything is a subject, predicate, noun, right? So if we have this node on the left, which is Ernest Scribble, right, Scribbler. So instead of attaching properties, you would attach this triple to assign a value to this node, right? So this node that represents a TV skit character, his name, the predicate name, is a string, which is Ernest Scribbler. And in the same fashion, you would tie a node to another node, right? Subject to another noun, right? So Ernest Scribbler went on to write the funniest joke in the world, which through the skit ended up being weaponized by the British government, so on and so forth. But you can see how this triple stores the information differently than a property graph. Okay, let me go back here for a second. And the last general broad category are multi-model databases. Now, multi-model databases aren't strictly graph limited, right? Because essentially, a multi-model database can have data stored in many different formats, right? Here, XML, CSV, JSON, and even other graph database formats. And the idea is to have a graph query language that sits on top and allows you to query through all those different document data stores. Okay, so those top 10 databases from earlier can be roughly broken up into these three categories. Some may kind of bleed into others, but generally these companies, these products are known in these broad categories. As you can see, Neo4j, the company that I come from, is a property graph. Amazon Neptune is considered a semantic graph, and Cosmos is multi-model. Redis, which I didn't put here, can be considered a multi-model database as well too, because Redis does allow you to run Cypher in a graph instance. Okay, so lots of companies, lots of products, which unfortunately means lots of different query languages are available out there, right? So it's kind of a zoo at the moment, but fortunately, smart people have gotten together, and there is a group that has come together to create a graph query language GQL standard, and it will be an ISO certified standard. This group got together in 2019, a few years back, and they are on track to have a official proposal or official spec by 2024, I believe. Now, graph query language, though it's when you read out the whole thing, it's basically the same as GraphQL. It is not the same as GraphQL, right? So GraphQL, of course, is the REST alternative that was developed by two gentlemen at Facebook. So it is a protocol for getting information, right? It's a REST API alternative. And now, to make things even more confusing, if you want to use GraphQL as the primary query language for a graph database, then there's a company known as dgraph that has created such a graph database that uses a flavor of GraphQL to query its database. Okay, so many options out there, but in general, GraphQL is not the same as the graph query language that is in development. Okay, the GQL is considering the future language based off these 10 popular existing graph query languages. Now, I'm not going to go through all of these, but I highlighted 3 that I think, if you have time, I would recommend taking a look into. So that is OpenCipher, Gremlin, and Sparkle. Gremlin is used both with Cosmos DB and Amazon Neptune. And Sparkle is maybe the oldest graph query language here, and it is used for the semantic graphs, right? The RDFs or triple stores. Sparkle's syntax is particularly unique because of that triple instance. And Gremlin is interesting because it has this builder pattern. So when you use the Python driver, your call looks exactly like the Gremlin query. So that's a nice feature. But I'm going to focus on OpenCipher. And the reason for that is I know Cypher better than the other query languages. Now, Cypher was originally developed by Neo4j, and then it was open sourced back in 2014. It is a declarative language that has ASCII art-like qualities. So above here, I've got an example query. You can see here we start a find or a match for a pattern, and then the pattern. So the pattern is made up of, you can see here, parentheses and brackets. Everything in a paren is a node, and everything in a bracket is a relationship. So you can see here, we're looking for a very simple relationship, right? Just looking for people who acted in a movie. And then we've got a where keyword as a filter. And we're looking for title of a movie that is The Matrix. And just return to me all the names of the people that acted in the movie. And in a simple movie database, just having a few of the key main actors, we would get returned this list of actors, as you can see here. Now, a more complicated example would be back to this earlier example that we had talked about of finding the actors from Monty Python to The Matrix. So you can see here that this query is actually only slightly more difficult. Just instead of a single pattern, well, we're looking for the same pattern twice, but for 2 different sets of movies. And then you can see here, we've got a shortest path function that goes and finds the shortest path between two sets of patterns, 2 sets of nodes. Okay. All right. So another reason why I was focusing on Cypher is the current direction for the GQL group is a very Cypher-looking syntax. So you can see here on the right, this is one example that I could find of what they had been working on. And this is a syntax for creating a simple graph, or it looks like the structure of a graph. And you can see here, it looks very much like Cypher in terms of parens for nodes, brackets for relationships. There are some other things that make it different from Cypher, but you can see that Cypher is very much part of its DNA. So if you learn Cypher now, it's kind of a good lead into whatever GQL will eventually be. Okay, so using Cypher, there is an official driver that is created and supported by Neo4j. And when I looked at all the other available graph databases in their query languages, everybody offers a driver, right? You got to have at least a minimum driver. So the Neo4j driver in particular has 2 unique features. One is using sessions and then having transaction functions. The transaction functions are basically static functions that has the actual Cypher query that you can pass arguments to, and the session handles retries and such. Okay, so the driver does allow you to easily add it to pretty much any general Python project that you might work on, whether it's using other frameworks like Flask or Fast API. I use it in Streamlit a lot. So it's fairly straightforward, but you do need to know Cypher, right? So to help with that, there are several community packages, and this is going to be generally true of all graph databases. There's going to be community tooling. There's going to be third-party services that make things easier. So here I'm showing an example of a query builder. So here you don't have to write a Cypher query and then pass the string into a driver directly, right? You could use a query builder, which allows you to write a query Pythonically, and then it will create the Cypher string for you, and then you put that into the driver. And the one thing I like about this community driver is that it adds in auto completion to Visual Studio Code and maybe IntelliJ as well too. So obviously making development a little bit faster. Now, if you don't want to deal with Cypher at all, you could use a package that includes an object graph mapper and not have to deal with that at all. So one good example here is GQL Alchemy, which was created by MemGraph, which allows you to basically build classes on top of base node and base relationship classes, and then call easier functions to kind of get certain relationships and nodes directly. The GQL Alchemy also interestingly includes a query builder with it, so you get quite a few options if you go a route like this. Next, of course, once you've got information going in and or out of a graph database, connecting a visualization tool goes a long way, and all the you can use pretty much any of the existing networking and graphing libraries and make them work with the output from a graph database. And the last sort of tool I want to go over is NeoDash or something like this, which is basically a dashboard that you can just run and not even know any Cypher to really just get started, and then just create all these little widgets, and then you can go in and tweak the Cypher or the underlying call, but you can basically create just like business data dashboards from the graph data right into another application of your choice. Okay, so that basically concludes my presentation about basically introducing graph databases to all of you. If you have any questions, if you'd like to reach out to me, you can send an email to me. You can reach out to me on LinkedIn. If Twitter is still running, you can tweet me there. So yeah, just hit me up. I'm